Welcome online lecture series. Our topic is equalization. Before we are going to see equalization, now some recap uh, about the system model where this amplitude or phase distortion signals are arrival. So see that this diagram where there is a first block which is the transmitter. When the signal is transmitted from the through this transmitter from the source, while it is reaching to the destination, there is some delay spread is generally in all the multipath objects, which results the inter-symbol interference. So it passes through the first of all channel channel, and after that it passed through the different specific environmentals uh, scatters. Due to that there is a propagation delay, so all the signals are not reaching in the same time, and that signals are also not on the line of sight, so we getting the multiple uh, propagation at the receiver side. So they should be adaptive in nature, so it is called the adaptive white Gaussian noise, AWGN. Because of they are in random in nature, so they are the time dispersive, so they should be added to each other. They are because of the vector sum, so we are added, and we whatever the distorted signal is coming, it should be removed before it uh, coming at the receiver side. So the removal section of the distorted signal is done at the equalizer. So this block is a equalizer. It will removing your all the attenuation signal. That attenuated signals are recreated or reconstructed in this equalization. So this much is we have seen in the previous lecture. So now we are moved to forward. We are seeing this is the simple model. So this one is the figure 1. So from figure 1 you can see it shows the system model where where a transmitter send information, information through a through a dispersive dispersive channel due to which due to which the channel channel output output is corrupted by the adaptive adaptive Gaussian noise, white Gaussian noise, white Gaussian noise. The task of the equalizer task of the equalizer equalizer is to eliminate the effect of channel from the transmitted information transmitted information and also to recover to recover it, and hence we get the we get the original original message signal. Original signal, that is the message signal message signal at the output of the of the receiver. So there is a message signal which is transmit to the channel. So what we do now, we are using the amplitude modulated signals to show this effect, like this here. We having a input signal x of t at the 4 level, and passes through the pass filter. The channel response h of t shows the coefficient of the channel behavior, and this behavior shows the signal is distorted or not. If the we getting the multiple signals, the multiple delay time is added. It is depend on the time dispersion. So after the passing from the channel, all are the adaptive in nature, including the noise. So we are also add the noise, and the output of this received signal is look like this. This is the received RFT signal. Now you can see at the receiver, we have seen the variation in the amplitude as well as the safe due to delay in propagation inside the channel, and that channel is shows the distortion that is attenuate the your signals. So effect of this intersymbol interference, we are getting this type of signal. Now see uh, what are the classification of uh, this equalizer. Classification of equalization. Under this heading, equalization is classified by the maximum likelihood sequence estimation and the filtering, because it is totally depend on the channel, or the channel having the two important function. First is the filtering, second you also know the adding the noise. So under this circumstances, our signal get effective. So we have to classify this equalization. Equalization is classified by maximum likelihood sequence estimation, MLSE. M stand for maximum likelihood frequency estimation. And filtering. And filtering. So filtering is further divided. Filtering is further divided into a trans universal filtering. Decision feedback. Decision decision feedback and adaptive equalizer. Adaptive equalizer. Adaptive equalizer. आइए इसकी पूरी चार्ट के थ्रू इक्वलाइजर देख लिया जाए. There is a tree. This is the first block. That block is divided into two parts. One is linear, other one is non-linear. So this is the linear. Entire bandwidth is constant. Non-linear. Non-linear. So this linear is further divided into the two part. One is transversal equalizer. Another one is lattice. So lattice is further divided into the gradient gradient now transversal is divided into a zero forcing right hand side left flat past RALS received line of or square root, और ये है स्क्वायर रूट। RLL RLS. Now non-linear is divided into three part. First is D F E equalizer, decision feedback. Second is maximum likely symbol deductor. और तीसरा है MLS. So decision feedback is further classified transversal, or transversal is LMS, RS, RAST, RLS, square root, square root, RLS. This ML symbol detector is further divided into lattice, now lattice equalizer is divided into gradient. Gradient RLs. So maximum likelihood sequence estimation is further divided into transversal transversal channel estimation. So this is the classification of the equalizer. So transversal filter, which is divided into the zero forcing equalizer or minimum mean square error. So that is called MSE equalizer. MSE, minimum mean square error equalizer. The decision feedback divided into using the past decision to remove the ISI contributed by the dam. Now ये दिखाने का मतलब ये है कि इनके जो टाइप्स हैं ये क्यों हैं कि चैनल से जितने भी हमारे डिस्टॉर्टेड सिग्नल्स, अगर डिस्टॉर्टेड सिग्नल टाइम के पे K1 पे +1 मिल रहा है, K2 पे K2 +1 मिल रहा है, K मिल रहा है, या K 1 -1 मिल रहा है, या K -2 -1 मिल रहा है, तो ये जितने भी सिग्नल्स डिस्टॉर्टेड हमको मिल रहे हैं, दिस आर दी रैंडम. सो रैंडम होने की वजह से हर एक इस के की वैल्यू इस प्रीवियस वाली वैल्यू पे डिपेंड करेगी. तो इसके इफेक्ट की वजह से दो सिग्नल की वजह से इंटर सिंबल होगा, इसकी वजह से ये वाली भी वैल्यू इस पे इफेक्ट पड़ेगी, इसकी वजह से भी इंटर सिंबल आईएसआई इंटरफेरेंस होगा. तो जब आईएसआई इफेक्ट हो रहा है तो हमको ये डिसीजन फीडबैक लेना पड़ेगा कि पास डिसीजन में जो हमने आईएसआई रिमूव करने के लिए जो कंपोनेंट्स हमने सिग्नल्स के लिए थे वो उससे प्रीवियसली कौन है. तो हर एक प्रीवियसली सिग्नल करंट सिग्नल्स पे आईएसआई पैदा करता है, उत्पन्न करता है, तो जिसकी वजह से हमको इतने तमाम इक्वलाइजर्स देखने को मिल रहे हैं. तो इन इक्वलाइजर्स को अगर हमने देखा और इसमें हमने इस पार्ट को देखा कि इक्वलाइजर आर यूज्ड टू ओवरकम द नेगेटिव इफेक्ट ऑफ द चैनल. एक तरीके से अगर इसको हम इस शब्दों में कह सकते हैं, इक्वलाइजर्स are used to overcome the negative effect of the negative effect of the channel. So in general, equalization is uh, partitioned into two broad categories. In general, in general, equalization is partitioned into two. So after dividing into the two broad categories, what are the that categories? These categories, first is maximum likelihood sequence estimation. पहला है पहला है मैक्सिमम likelihood maximum likelihood sequence estimation. शॉर्ट फॉर्म में MLSE यहाँ पे हम इसको लिखते हैं, और जिसके अंतर्गत in which in which in details making a making a measurement of channel measurement of channel impulse response impulse response then and then and then providing a means for means for adjusting the receiver adjusting the receiver to the transmission transmission sorry environment environment for example Viterbi और सेकंड पॉइंट है जो कैटेगरीज है वो है इक्वलाइजेशन equalization with with filter uses filter to filter to compensate the distorted pulses. Trans- Distorted pulses where which is in figure 1. This is the we having the figure, we applied the input, that is the x of t, which having a channel input signal x of t is given channel h of t. We putting the equalizer one of h of f and multiplied by these two terms, we getting the original signal. This is the journal channel and Equalizer equalizer. So it is the channel equalizer. You can give a name channel equalizer. Equalization. So check out channel equalization. अगर हम बात करें तो most of the times we can typically in a in a wireless channel we having a signal and the wireless channels typically you can say have a have a such type of signal y of at time k is equal to response of channel input signal at time k plus VR channel noise. We having a such type of generally typically lot of the way you can express the wireless channel. Now I am taking in this way. So here this y of k, y of k is symbol of uh, received, symbol received at time k. This is so. This is the symbol we have received at the receiver at time t. This h is trading channel coefficient. Now this x of k is transmitted symbol at time k, and this vr is the noise at time this is the noise symbol time k. So I have a y of k signal is the product of fading coefficient and input signal plus noise from the channel. So it is observed that it is observed that in this model we observe we have modeling the our signal in a channel. So we observe in this model observe that current output or symbol y of t depends only on the current input symbol x of r. The current output symbol y of k depends not only the current input symbol. So so in another scenario we can might happen we have a uh, s- signal like y of k is h of naught x of k plus fading coefficient h of 1. The next signal k minus 1 plus v of k. So look at this. This is the transmitted signals. So you can say this is the current symbol at time k. This one is transmitted symbol symbol at time k. This is also transmitted symbol at time k minus 1. So basically we observe that the output of symbol y of k at time k depends depends not only on x of k but also previous previous symbol x of k minus 1. So, so essentially x of k minus 1 is interfering